Yeah. Right, I think you should be able to hear us now. Where you're taking in sound. Yeah.
We leave that ball there to kind of guide us.
Yep.
Right? Out of the way, guys. Yeah, because they might, if they
There it goes. Alright, nice.
we leave that ball there to kind of guide us. Right? Out of the way,
I would do this. Yeah, so it doesn't.
Yeah.
Should we slow it down a little bit? We don't have that vibe.
I don't know.
What is the plan for moving things from that side?
No, because it turns in 6,000 so we cannot
It's probably easier for some. We already take back and I. No, I think we should both move back.
He's like too old.
Yeah, we can argue more, but like we're also kind of pushing I think the lower end. Oh, look at that bumper. You go drop the gear off? Yeah, I mean, yes. You have gears up? As long as you the sheet works. Oh my. Oh my. Alright, now we just lift it. So now you lift it up.
So in the actual thing, the attachment piece
Let's. Can we get that again from the PlayStation? And let's try to keep it. Okay, yeah. Let's go try. Oh, from the stage. Okay, yeah. We'll load it. We'll load it. You gotta load it up first. Okay, we'll leave this over here.
Careful, no
Nailed it.
Back
Back up. Okay. Then lift it straight up. Oh, that's beautiful. That's beautiful. That's real nice. That's real nice. Oh, at the rudder. Yes. Spin it. There. Oh, yeah. Okay. Here we go. Ready? Go. This is going we didn't have sound earlier. We have sound now. Everyone, I was just told that we didn't have sound earlier. Welcome to the live stream. Sorry I got started a little bit late. We basically just started testing the code about 10 minutes before noon. You saw us shoot the ball, now we're testing out the gears. Thanks for watching. If you guys have any comments or questions or want us to try something with the robot, it's supposed to comment there. And we're open to names. We're going to name this robot. It might even have a blog. So if you have any ideas, you can just let us know there. And any comment, check out our other, we posted a day 3 and day 2 update videos. Post any comments there with names or any other ideas, or any other content you want to see on this page. Live view for FRC updates, cool student applications. Let us know, we'll make it happen. Thanks for watching. Good idea. Oh yeah, so they can see what's happening. They can see like, yeah, so we're like about 90 degrees in. Yeah. There's a few second delay.
That one's good.
Right. Yeah. I was just trying to like center on it. Yeah, does someone want to kind of explain, like, from a technical standpoint, why, like, the design decisions and iterations and stuff real quick? Who was the lead on this side? Who was the lead on this? Who's on this team? Do you want to? So here's a good spot to stand about right.
This is the live one.
Yeah. Here's a good spot about right here. You maybe explain the design decisions that went into it and how we came to the.
So after reading through the rules, it came to several of us at pretty much the same time a very non-moving design for the gear. We realized that the gear, if you let it fall and drop, it can land vertically and be at the right height for the spike to reach it. So it was really funny in the discussions. Literally, we had it drawn and we were talking about it, and then we just spun it around and it was like, and we started drilling it. Now, what you can see with it is essentially we have a gap in the front so that the spike can be stuck in, and because the user pulls it up, there's no need for mechanic moving parts. We just have to put it in the right place and get it onto the spike. Now, one of the difficult parts is the arrow on the spike. Is you have to actually get it in deep enough so that when it's lifted, it doesn't just slide off. So with this, we have it kind of at a curve so that the robot can kind of move forward a little bit as it's being lifted to make sure that it stays on the spike. Now, one of the stipulations we made was that we only cared about its position in teleop. And because we can place the gear in teleop where it's aligned perfectly, it's very reliable for doing just move forward onto the spike, let the person lift it out, and then the robot can continue on its autonomous. In a teleop, there's enough of finesse with the movement of the robot and the driver to allow you to essentially jiggle it a little bit to get it in. Now, when we were loading it, which you can see in a little bit, we actually saw that it can land and gets kind of stuck occasionally, depending on how it hits. But because of the way the center of mass is on the gear and the way it's positioned, it's a simple matter of shaking the robot, and it falls right into place, and we're ready to proceed. So that about covers it. We moved from a very simple prototype made with Tetrix Prime and cardboard and duct tape, and went ahead and once we put that together, to get the kind of the dimensions right and test some initial things that were a little bit loose, we recognized we needed something stiffer. We decided to go with something quick and easy, which is the foam board. And so far it's been holding up exceptionally well. I don't know if it would last for a full season, but definitely as a second revision prototype before we get into maybe even manufacturing, something that someone without any mechanical training can go ahead, get done, and get on a robot to test.
It's the duct tape that adds probably stability.
Yeah, and durability.
All right, let's test it out. Let's check it out.
Testing the gear.
Testing the gear. Hey!
Ready? Pulling up.
It feels good to applaud ourselves.
We did good. It was
I'm applauding the robot
That's right. Well done.
and the driver.
CB.
no, Jacob's time.
Robot, big robot.
Thanks,
We get more?
Honestly, the battery's pretty low, so we might not be getting
Believe in us.
we would try to keep probably, there might be more upstairs.
So you might not be able to hear, but we're concerned that our battery is getting low. But we do have a backup in the wings to bring on board. It's really good when you don't do the things hanging on there, but still pretty much bouncing.
Yes. Reload, get all the balls into the hopper, aka your arms.
Not the actual hopper. The functionality is not even tested. Yeah. Alright, so the trick is to go in from the side so you don't get the hand on that.
Oh wow. Sometimes the battery is out when it goes a little slower. Don't move it. It's doing good.
Anything else you want to demonstrate on? Team. Just go handheld. Can you follow me with the?
All right. On handheld.
All right, guys. We decided not to do the climber. Kind of ran out of time. Let's meet the team. Are you ready? Miles over there. How do you feel about how everything came out?
I guess it was okay. Yeah.
Oh, reconnection
Could use a bit more time, but everyone can use more time. So I think we did pretty well first time. I think a lot of progress. We were able to go through a lot of like the life cycle, a lot of revisions, planning, prototyping, testing, and then cycling through. So I think it was a really good opportunity to go through FIRST competition.
Cool. All right, let's go meet some more of the team.
Oh, hello.
All right, we got Jordan here, CAD expert.
Hello. My name is Jordan. I did a lot of CAD. I think I went through 7.
Let's stand this way. We're getting like a loop with the background.
Alright, we got this.
There you go.
I got like 7 revisions in, and most of those were like in the last like 24 hours. It's crazy. I don't know. I mean, like positioning stuff was really pretty difficult to at least just do freehand. So getting some of those dimensions was like pretty good to see. Like, hey, where's the ball gonna fit? Like, is it gonna get pulled in? We don't know. So let's figure it out with that and CAD.
When you're working on the CAD, did you save a bunch of different revisions of your CADs?
I did.
Is that something you would post for our viewers if other teams are looking at just as a starting point for CAD drawings?
Yeah, definitely. I mean, they're a little rough, but definitely you can still use them. I mean, the idea is still sound, I think, regardless of the implementation or whatever, bugs are working.
Cool.
Yeah.
All right, we'll post that online, and we'll put a link down in the comments there when we get that up. So teams want kind of a starting point for CAD, and obviously we're iterating. We only had a few days. You're going to want to definitely spend some more time on it and customize it the way to meet your team's goals. But we'll have that up as a starting point or just as a reference for you guys. Thanks, Jordan.
Yeah, just every question at once, right?
Yeah. April, project manager, team leader.
Hi.
How are you feeling?
Good. I'm really happy it all mostly works. I'm really happy it shoots as well as it does. I think that's awesome. Our drivetrain came together really nicely, and that's really cool. Overall, I'm really proud of our team. 6 hours ago, there was just a drivetrain. So I think we pulled a lot together really quickly, and that's really cool. We've had a request from the live stream for more close-ups of the actual robot.
Oh, good call.
And the actual mechanism.
Let's do that. Your wish is our command, live stream viewers. So let's talk about who was on the shooter team.
Shooter team was mostly, that was like almost a one-man show.
Where's Travis?
Standing over there.
Okay, that's fine. Let's come back to it.
Driven?
We're so close. Why is Callie holding all the balls?
Travis, come on up. Hello. This is Travis.
Hello, I'm Travis. I'm here to talk about the shooter.
Yeah, we had some requests for close-up, so I'm just gonna. You can look on the screen here for like what we're looking at, and just kind of point to stuff and talk about things.
Yeah, so this area right here is the shooter mechanism. So a ball A ball comes in through the front here and launches through these pneumatic tires. We're driving them directly. These are the 8-inch pneumatic tires. I'm not sure where they're sold, but we got them from team 2468. We're driving it directly off of a sim motor at about 50% power. That's giving us a pretty good shot. The release angle I'm not exactly sure on, but the way we built this was we have a strip of aluminum sheet metal back here, and we packed this whole shooter with balls, and then let's do that. Tighten it up.
Someone grab a few more balls, please.
Kelly. Yeah, so we packed the whole shooter with balls. You're ready. As such, to make sure we had contact.
We call her the hopper.
That's good enough. That's good enough. So just like this, when we are assembling it, we packed it just like this, so that we made sure we had contact the whole way. And the sheet metal itself back here is only mounted at the top and at the bottom. So this spacing makes sure we have contact and gives us a really nice shot. It's basically just sheet metal.
We went it concentric, right?
Screwed into a 2x4, and adding these balls makes sure that it's concentric to the wheels that we're using. So, yeah,
Cool. Any other components? Any other ideas? What was it? How far did this deviate from the original design?
So it didn't deviate too much from the original wheeled shooter design. The biggest part is these pneumatic tires right here. They're squishy and they allow to get you really good traction on the ball for that shooting. They are a little unstable at high speeds, so you have to be careful about that. But they're nice and squishy, and so you get good compression and.
Did you know to use these wheels from the beginning?
So we'd seen them in shooters before. The wheels we used in the beginning were hard rubber wheels that we had lying around, and they didn't get any of the grip we needed. So we went and borrowed these wheels, and they worked really well. Really happy with how it turned out.
All right, thanks, Travis.
Of course.
Let's see, who put together all the motor controllers?
So that was me.
Let's look at that.
I did all the electronics.
April on the electronics. Let's talk about Robo Rio, April.
Sure. So, as is with all FIRST robots, it's being controlled by an NI Robo Reel. So this gray square here is running all of that's actually the brain of the robot, so it's running everything. We're taking all these inputs from the talons, controlling the power to them, and then all of our inputs and outputs are over here on our PWM lines for our motor controllers. So they're over here, and you can see the status lights here.
Wait, the status lights here. Why don't you take the camera and you can talk about. Here's your stream over here,
Yeah.
so that way you know what the viewers are seeing and you can talk about those.
Interesting.
So those are the Robo Rio status lights there. You can see that the red comm light means it's communicating and blinking.
If you're not sure what the status lights are, you can find it in the user manual and the specifications for the Robo Rio, which you can get on ni.com/FRC.
So those are all our PWM lines. Those are controlling all of the motors on the robot, so all 6 of the sim motors, and then our 1 servo to control our gate. And then we have all of our Talon motor controllers over here. There's actually 8 of them, 2 of them are hidden here. And you can see that we have our main power fuse over here, which is easily accessible in case anything happens to the robot and it starts acting weird. It's important that that's easily reachable. So you'll notice that we've kept all of our sort of signal LEDs pretty visible on our robot. That's really helpful for debugging, and especially at competition. If we can see those lights, it's a lot easier to help you guys figure out what went wrong. But yeah, you've got your PDP over there, and that's basically the control system. Back to you.
Yeah, thank you, April. And I just, as you were talking, I walked around. I realized that this is the first time I've actually looked at our hopper. And if you guys are interested, if your custom design requires a super janky hopper that's put together at the very last minute, this is something you might want to consider. Who's on hopper design?
It's structural foam core.
Their design.
I don't think we should refer to it as hopper design at all. I don't think there was any hopper design. Hopper was just kind of like, we'll get there. And then
We did, kind of.
At 11:40.
Yeah, like
Yeah.
20 minutes, guys. Oh, the hopper.
So I'd like to say that we did stick to our priorities. Our priorities was the gear slot on the front, and the high shooter, and the intake. We didn't get to 4, 5, or 6. We started with top 3.
Here's the intake.
We had some great ideas for the climber.
Passive intake. Okay, now we haven't demoed the intake yet. What's going on with that? We're gonna talk about it.
Yeah. So
This is well. Why didn't we demo the intake?
we're working on it. It might be either something in our code, or for some reason we're just not able to get this motor to run. We're able to get it to kind of pulse. We're not able to get it to run at this point.
Can we show theory of operation?
Yeah, we can totally do it just manually.
So wait, are you saying that engineers aren't perfect the first time every time?
No, I would never say that. And don't quote me on that. But yes, we are human beings, just like everyone else. I'd like to think.
So let's talk about the design and the theory for the intake.
Right.
And then we can talk about maybe why it's not working and what we would do moving forward if we had another 41 days.
Oh, another 41 days. Oh.
So, but first let's talk about the design and the theory of the intake and how it ended up looking like this.
So the theory of the intake is, as a pretty good general rule for FRC, if you need to pick up a ball, the best thing to do is have kind of an active pickup. So you want to try and pull the ball into your robot. Best way to do that is to interact with the ball is to spin it. So you kind of try to grab the ball, spin it up into your robot. And so if this spins and there's a ball in place, which we can actually put a ball there and spin it, it should, in theory, go up, except ours doesn't. But it should. There's so many things that could be improved on, but given time, it's the best we've got right now. Actually, something's kind of jammed in there almost. There. So your intake just does that. It gets jammed, and then through sheer force of will, throws the ball halfway up your intake. Yeah. And then from there, it's like butter, but butter that you left on the counter for days, maybe weeks.
Someone should talk about how it cascades.
Yeah, so, well, a couple of things. In order to get it up from the drum kind of at the bottom, we have a series of belts running up to just kind of compact the ball, the friction between the belts and the ball kind of grips. It'll roll the ball up along the back wall, which is just made out of sheet metal. Ideally, we would have had different tubing, but we made do with what we have, and it kind of works. At the top, we've got a whole bunch of zip ties in a fun spiral cascading pattern. The idea,
cool.
The idea is basically that, like, for a ball that came in on the side here, we would want to move it over to towards our shooter. This was kind of a last-minute thing because of the whole hopper 20-minute design session at the end, but since we didn't have the time to put the proper hopper, that rhymes.
Proper hopper, that's what it's called.
I like it. The idea of the zip ties is that they're kind of in like a cascading pattern like this. So if there is a ball here and this spins, it'll tend to like try to move the ball across towards where our shooter is. I think if this was running, we could basically just throw a bunch of balls in here and then they would kind of file them towards the shooter in a semi-acceptable way. And then we would be good. And all of this this is just hopper space. We did it. So.
I kept asking earlier. We were like, all right, listing all the things that we have left, and I was like, hey, what do we do about the hopper? And the plan is the hopper fits around everything else. So whenever everything else is on the robot, we'll just make space for the hopper, and we'll call it the hopper.
Yeah, look at all this! Look at all this sweet hopper space right here. Like we could get a cardboard box right now and increase our hopper space by like 50%.
That was like at 12 blocks, right?
Yeah. So this was at about midnight. Midnight last night, we made a list of things that were left, and if there's an arrow from one thing to the other, that's the order in which things have to be done. So, for example, we complete the shooter, and we can't do the feeder until we've completed the shooter, because that's going to depend on where that is. We're currently building gear support. That's when Clemens was in the machine shop. and we couldn't attach the gear support until that was built. We also couldn't attach the gear support until we completed the intake. So both of those had to get done. Once we completed the intake, we could complete the scoop, but we couldn't do the feeder until both the shooter and the scoop were completed. And then once that was done, then we could finally get to the hopper. And so you can see, because of all this, we ended up with this.
All of this.
All of this.
Beautiful.
Not just
directing.
So let's talk about how things could. Let's talk about why the intake doesn't work. And let's say that we were a first team and we had 39 more days. What would be the next step in fixing, just at least getting the intake working? So why it doesn't work?
The first thing I would do is test the motor. I would take the motor off and I would test it on its own, make sure that it runs. If it does run, then you can kind of narrow down that aspect of the system.
So we tried running the motor. It does run when not being run off of the software. Like we just give it power when it runs. But that's not a safe thing to do. So we don't want to do that. Actually, that was just like, test it. Does it actually spin? Yes. So we think it might be something in the software. If not, it might just be, it might not be getting enough power in order to run to overcome just like, just the static position, overcome all the forces necessary to actually get up to speed and rolling. Other things we would do with our current roller, you saw like, oh man, it kind of didn't pull in as well at the front there. So things we might do is like try to lower the scoop at the beginning so that maybe the ball's getting pinched too much between the front roller and that scoop, so it can't actually compress enough. So we might try dropping that down a little bit or bending that to give us a little bit more space. We might try like different materials on the end, like maybe a squishier material so that it can grab the ball and just compress a bit and get past that jam essentially. We might also try different belts to see if we had improvements in its ability to like get pulled along effectively. We do notice that there is some slipping with the belts that we use. So if we had like some polyurethane belting or even surgical tubing would probably be other good options for us to try. So that would help us actually carry the ball up. And then at the end, in terms of like getting everything over here, we could probably, if we had more time, instead of having cascading zip ties, which are a bit floppy, have a more rigid system for pushing the balls off to the side. So like some kind of like a bristle, or just putting something more rigid than a zip tie, so that it'll actually like you'll have a ramp and the zip ties just won't bend out of the way and get rid of that cascading effect of it.
And I think another thing that we learned, we didn't really start working on the code until yesterday.
Yeah.
And so we, that's something like, definitely don't wait until the end of code starts. There are definitely
Don't wait for your 5-week equivalent to start code. But that was just, we did the best with what we had. And I think overall, for a 3-day rookie build, I think we came out pretty well.
So Ethan, I know this comes up sometimes, especially on rookie teams. When do you start coding? How do you code if you don't have a fully built robot?
So you can make kind of you can take your electronics board, you can work on an electronics board off of your robot. So let's say you don't have room to mount all of your motors yet because the
Let's pause and say bye to Travis.
Bye,
goodbye,
Travis! Thank you so much for your help.
Yeah, it was a lot of fun. Glad we got it done.
Go sleep.
Yeah, I'm gonna sleep and then fly back to WPI. So yeah, y'all have a good rest of your day.
Take care,
Goodbye.
Travis.
No gun.
Oh,
the robot is by.
It's alive.
It waved. What?
Wait, did you guys make it work?
Brian.
Oh, wait, so the intake work now?
Brian was probably.
It went backwards.
That's close enough.
Wait.
What did you just do?
But how are they?
So what happened
going the wrong way.
It's going backwards, guys. Run it the opposite direction.
or backwards.
We're not doing anything.
The issue is we had it set to go forward, which is the proper intake, and somehow we are still trying to figure out why that's not working. But once we rotated it back to go backwards instead, as you can see, so it's driving.
So it may be getting caught on something is what that means.
Oh, it's going like blank and then glowing red and then going back off.
Yeah, that battery is super low too.
It's like, yeah, that's probably like overamping maybe.
So this is the tower posture that you can come on, and when it comes on, that motor is turning, and when it's off, that motor is theoretically not turning. I think we're just running out of battery voltage, given what the driver station is showing us.
All right, let's talk about the drive base. We haven't talked about that yet. Drive base, the chassis.
Oh yeah. So we use the Andy Mark, basically the kit bot that comes with the for rookie teams. You got a standard 6-wheel drive, a couple of different configuration options to make it long or wide or square. We opted for the wide configuration, but all of the instructions tell you for the wide configuration you can go 24 inches by 31.5 inches. But because of this is the same kit chassis that was given out last year, so it's not updated for the new volumes that the rules mentioned. So you can actually go a couple of inches longer and cut your chassis to like about a 29 by 31.5, and still be clear. So it's the wide chassis, but it doesn't look quite like the wide chassis in the pictures because it's more square-ish.
And we didn't get a frame opening kit from Andy Mark that you can get. We customized the frame opening, right?
Yeah, so we just cut through the seat channel at the front in order to have an opening for the balls to come in, and then we just took a piece of 1x2 aluminum tubing and put that across at the bottom there to make sure that our chassis was braced and wouldn't twist and bend in all sorts of fun ways.
All right, guys, we're gonna leave the live stream on for a little while longer as we play with the robot for another few minutes. If you guys have ideas for robot names, post it in the comments there or comment on any of our other videos. And keep watching this channel. We're going to be posting a lot of very short how-to LabVIEW for FRC videos, 30 seconds to a minute, of everything from the environment to more complex coding, and all kinds of stuff like that. So you can see whether you're a beginner team, an intermediate team, or a pretty advanced user, we're going to have something for you that will help you get your code developed and working. Any other content that you guys want to see on this page, just let us know. We'll make it happen. I'm Jeff. Thank you guys so much for watching, and thanks for your support.
Goodbye. Are you lingering on us?
Yeah, I'm gonna linger.
I still need to eat and also be on shift, so
Okay, cool.
I think it is battery voltage because the current dropped. I mean, the current dropped to 9 volts, and I think it was the internal brownout system. Good thing. Very successful. What? Oh, sorry. No, I think it was very successful.
The main thing is I just have to sell all my stuff. Yeah.
What? Good robot.
Andy Mark sticker.
Oh.
Somewhere.
Yeah. It's funny is that the way you guys had mounted the gear thing, it worked really well. I like that. It worked really nicely.
Let's go and do like a group shot going back to the... How about this? Thank you, Andy Mark. We're gonna add this, and the reveal video will prominently display this.
All right.
All right. Nice job. Team National Instruments. Gonna do the wave?
Oh god, not again.
Let's do the wave.
No, we've been through
We're gonna do Team NI and then you start the wave.
The wave is incredible.
1, 2, 3. Team NI. We're consistently good at this.
Yeah, we have the best.
We Team NI and then go. 1, 2, 3.
Team NI!
Woo! Bye guys. Thanks for watching.
Bye.
Back to the wave.
You just said do the wave. All right.
That's definitely. Jenkins time. It's like Frankenstein because it's made of lots of pieces and shouldn't be alive.